All right, so we're moving into reactions of alcohols. And to start things out, I like to do this question. So essentially, two reactions are up here. Which reaction is less favorable? So what's different? We have the same nucleophile. We have different leaving groups, OH versus Br. So favorable reactions have stable products, and unfavorable or less favorable have unstable products or less stable products. Unstable product. So which of these is less favorable, A or B? So hopefully you've written something down. You've tried to rationalize it to yourself. So it's the identity of the leaving group that's different. So which of these is a more stable leaving group? And the answer is that this bottom reaction is less favorable, and this is more favorable. Why is that? That's because Br minus is a better leaving group compared to OH minus. How can we kind of put a value to that? Well, how stable is OH minus as a conjugate base? H2O has a pKa of 15.7. HBr, we don't know its pKa, but we know that HCl has a pKa of -7. This is a stronger acid than HCl, so that tells us that this is going to be an extremely stable conjugate base, and that means that it would be an extremely stable anion by itself and a really good leaving group. So this is a really favorable reaction, and this reaction below is not very favorable whatsoever. So what was our leaving group in the non-favorable one? It's hydroxide, and essentially hydroxide is a very poor leaving group. Very poor leaving group. And essentially the last blank on this page of the course note says there are methods to do substitution and elimination reactions of alcohols. So this would be a substitution reaction of an alcohol. And all of them somehow make the alcohol into a good leaving group. That's the blank that is on your course packet. All of them somehow make the alcohol into a good leaving group. And to do that, what they do is they make the alcohol neutral. Right now, as a leaving group, it would be neutral. So essentially, they transform OH into OH2+, which when it leaves, it looks like water, which is very stable by itself, right? We know that. Essentially, that's what we're going to see here when we do substitution or elimination reactions of alcohols. We're somehow going to use a reagent that transforms this into a good leaving group. So more on that soon.